Traceroute is a fascinating tool that reveals the journey your data takes across the internet. Imagine sending a message from your computer to a server miles away. Traceroute tracks each hop along that path, showing you every router your data encounters. It's like a digital road trip. When you run the command traceroute example.org in your terminal, you'll see a list of IP addresses, each representing a stop along the way. You'll also notice the time it takes for each hop, giving you insight into where delays might occur. This is invaluable for diagnosing network issues or just satisfying your curiosity about how data travels. So next time you're curious about the route your data takes, remember Traceroute. It's your window into the intricate web of the internet. Traceroute is a fascinating tool that reveals the journey your data takes across the internet. Imagine sending a message from your computer to a server miles away. In this lab, into another exciting use case of Traceroute. Let's run the command route and example.org. The N flag is a game changer. It skips the hostname resolution, giving us faster results. As we execute this command, pay close attention to the IP addresses and the time delays at each hop. Each hop represents a detour along the path to the destination, and the time delays show how long it takes for data to travel between them. It's like taking a digital road trip, where each stop how our data navigates the internet. Notice any significant delays? That could indicate congestion or issues along the route. Understanding these details can help us troubleshoot network problems effectively. Keep exploring, and let's see what insights we can uncover. When you run the Traceroute for example.org, you're diving into a fascinating journey of data packets across the internet. Each packet travels through a series of routers known as hops, and Traceroute reveals the path it takes. You'll see the IP addresses of each hop, along with the time it takes to reach, measured in milliseconds. This latency gives you insight into network performance. If one hop takes significantly longer, it could indicate congestion or a problem in that segment of the network. It's like a digital road trip, where each stop tells a story about the health of your connection. By analyzing this data, you can troubleshoot issues or optimize your network. So next time you're curious about your internet's journey, remember, Traceroute is your map to understanding the complex web of connections that keep us all linked. forces Traceroute to use IPv6 only by utilizing the command Traceroute and example.org. This command is a powerful tool for network diagnostics. By specifying the N flag, we skip DNS resolution, allowing us to see the raw IP addresses in real time. This is particularly useful when troubleshooting connectivity issues or analyzing the path packets take to reach their destination. When you run this command, it sends packets to the target and reveals each hop along the way, showing you the routers and their response times. With IPv6, you're not future-proofing your network, you're also navigating a less congested space. This can lead to improved performance and reduced latency. Understanding the output can help identify where delays occur, whether it's a slow router or a misconfigured network. So next time you're curious about how your data travels across the internet, remember to use Traceroute and clear, concise view of the journey in the world of IPv6. Forces Traceroute to use IPv6 only by utilizing the command Traceroute and example.org. This command is a powerful tool for network diagnostics. When you're troubleshooting networks, understanding how data travels can be crucial. That's where the Traceroute command comes in. By setting the wait time for a response to 5 seconds per hop, you're giving each segment of the journey a fair chance to respond. This means you can pinpoint where delays or failures occur in the network. Imagine sending a message across a series of bridges. If one bridge takes too long to respond, you know exactly where the problem lies. This 5-second window is the sweet spot, long enough to catch a lag, but short enough to keep the process efficient. It's like having a reliable GPS that not only shows you the route, but also alerts you when a road is blocked. So next time you run a Traceroute, remember that those 5 seconds are your allies in navigating the complex web of the internet. When it comes to network diagnostics, the way we trace routes can make a big difference. Typically, tools like Traceroute send 3 probe packets per hop, but what if we ramp that up to 5? By increasing the number of packets, we enhance our chances of getting a clearer picture of the route taken by data. Each packet acts like a little scout, gathering information about latency and potential bottlenecks. With 5 probes, we can better identify intermittent issues that might be missed with just 3. This means more reliable data, which is crucial for troubleshooting and optimizing network performance. Plus, it gives us a more robust understanding of how our data travels across the internet. So, next time you're analyzing a network path, consider sending those extra 2 packets. It could be the key to uncovering hidden problems and ensuring smoother connectivity. When using the Traceroute command, one of the key parameters you can set is the maximum number of hops, which defaults to 30, but can be adjusted down to 20. Why is this important? Each hop represents a router your data passes through on its journey across the internet. By limiting hops to 20, you can effectively manage your network diagnostics, especially in complex networks. If your data can't reach its destination within those 20 hops, it's a clear sign that there might be an issue along the route. This can help pinpoint where the breakdown is occurring, whether it's a misconfigured router or a network congestion point. Plus, keeping the hop count lower can speed up your troubleshooting process, allowing you to focus on the most relevant paths. So, next time you're running a Traceroute, remember that setting the maximum hops to 20 can streamline your analysis and enhance your understanding of network performance. When using the Traceroute command, one of the key parameters you can set is the maximum number of hops, which defaults to 30 but can be adjusted down to 20. Why is this important? When you think of Traceroute, you might picture it as a tool for network diagnostics. But did you know it can also be a powerful ally for web developers? By using port 80 for Traceroute probes, we can specifically target HTTP servers. This means we're not just tracing the path of packets, we're mapping the journey to websites. Imagine sending out a probe that reveals every hop your data takes to reach a server. You can see where delays occur, identify bottlenecks, and troubleshoot connectivity issues, all while focusing on the HTTP traffic that powers the web. It's like being a digital detective, uncovering the mysteries of network performance. So, the next time you run a Traceroute, consider using port. It's not just about finding the quickest route. It's about understanding the entire landscape of web traffic and ensuring your online experience is When using the Traceroute command, you might not realize how powerful it is in diagnosing network issues. One of its lesser-known features is the ability to specify the source IP address for outgoing packets. This is particularly useful when you're dealing with multi-home systems, those with multiple network instances. By default, Traceroute uses the system's primary IP, but what if you want to test a different route? By adding the S option, followed by your desired source IP, you can see how packets travel from that specific address. This can help identify routing problems, performance issues tied to a particular network interface. It's like having a backstage pass to your network's performance, allowing you to pinpoint where delays or failures occur. So, next time you're troubleshooting, remember that specifying the source IP can give you deeper insights into your network's behavior. When you think about network diagnostics, Traceroute is a powerful tool that often flies under the radar. Unlike other tools that might use UDP packets, Traceroute relies on ICMP echo requests. This choice is crucial because ICMP is designed for network troubleshooting. When you send an echo request, you're essentially asking each router along the path to respond, giving you a clear view of the route your data takes. This method allows you to pinpoint where delays or failures occur in the network. Each hop provides valuable information, like the round-trip time, helping you identify bottlenecks. Plus, since ICMP is a fundamental part of the Internet Protocol Suite, it's widely supported and understood by devices. So, next time you need to trace a route, remember that those ICMP. Traceroute or Traceroute is a powerful tool that uses TCP SYN packets to map the path your data takes across the internet. When you send a SYN packet, it's like knocking on the door of each router along the way, asking, "Can I come in?" Each router responds, revealing its IP address and the time it took to respond. This process helps identify where delays or failures occur in the network. What's fascinating is that by using TCP SYN packets, Traceroute can bypass some firewalls that block ICMP packets, which are typically used in traditional traceroute methods. This makes it a stealthy option for network diagnostics. Plus, it provides a clearer picture of the route taken, especially in networks. So, next time you're troubleshooting connectivity issues, remember that Traceroute with TCP SYN packets can be your secret weapon in uncovering the mysteries of the internet. When you use Traceroute command, you might think it's all about finding the path your data takes across the internet. But did you know it uses UDP packets to do this? That's right. Traceroute sends out these user datagram protocol packets to each hop along the route to your destination. Each packet triggers a time-to-live countdown, and when it hits 0, the router sends back an ICMP error message. This clever dance allows you to see the round-trip time for each hop, giving you insight into network performance and potential bottlenecks. Using UDP means Traceroute is lightweight and efficient, perfect for quickly mapping out routes without the overhead of establishing a connection like TCP does. So, next time you're troubleshooting a slow connection, remember that Traceroute isn't just a tool, it's your guide through the maze of the internet, revealing the hidden paths your data travels. When using the Traceroute command with the Z option set to 0.5, you're essentially telling your system to pause for half a second between each probe it sends out. This can be incredibly useful for monitoring network performance. By slowing down the probes, you can get a clearer picture of how each hop responds, especially in networks that might be experiencing congestion or latency issues. Imagine tracing the path to a website and noticing that one particular hop takes longer than the others. With that 0.5-second pause, you can pinpoint where the slowdown occurs without overwhelming the network with rapid-fire requests. It's like giving each router a moment to catch its breath before moving on to the next. This method can also help in troubleshooting, allowing you to gather more accurate data on response times and packet loss. So, next time you're trying to diagnose a network issue, consider using Traceroute Z0.5. It's a simple tweak that can provide deeper insights into your network's performance. When using the Traceroute command with the Z option set to 0.5, you're essentially telling your system to pause for half a second between each probe it sends out. This can be incredibly useful for monitoring network performance. When using the command Traceroute F5, you're diving straight into the heart of the network. This command tells your system to skip the first 4 hops and start probing from the 5th. Why would you want to do this? Well, sometimes the initial hops can be noisy or irrelevant, cluttering your results with data that doesn't help you troubleshoot. By starting at the fifth hop, you can focus on the more critical parts of route, gaining insights into latency and potential bottlenecks further down the line. It's like skipping the appetizers and going straight for the main course of your network path analysis. This technique is especially useful in complex networks where the first few hops are local and don't reflect the performance of the wider internet. So, next time you're diagnosing connectivity issues, remember to leverage the power of Traceroute F5 for a clearer view of your network's performance. When using the tracer command with the G option, you're diving into the world of loose source routing. This feature allows you to specify a gateway through which your packets will travel on their way to a destination. Imagine you want to control the path your data takes across the internet. By using Tracer G, you can direct your packets to take a specific route, which can be useful for troubleshooting or optimizing network performance. This command is particularly handy when you suspect that certain paths are causing delays or packet loss. By routing through a specific gateway, you can test different paths and see how they affect your connection. Just remember, loose source routing isn't always supported by all routers, so results may vary. It's a powerful tool in your networking toolkit, giving you insight into the journey of your data and helping you ensure it takes the best route possible. When you run Tracer MTU, you're diving deep into the network's underbelly. This command helps you discover the maximum transmission unit, or MTU, along the path to your destination. Why is this important? Well, the MTU determines the largest packet size that can be sent without fragmentation. If packets are too big, they get chopped up, leading to delays and potential data loss. As the command traces the route, it sends out packets with increasing sizes, checking each hop along the way. If a packet is too large for a router to handle, it sends back an ICMP message, revealing the MTU limit at that point. This process not only helps optimize your network performance, but also aids in troubleshooting connectivity issues. Understanding MTU can be the key to smoother, faster data transmission, making your online experience much more efficient. So, next time you hit a snag, remember the power of Traceroute MTU in your toolkit. When you run the command traceroute back, you're diving deep into the world of network diagnostics. This command not only traces the route your data takes to reach its destination, but also reveals the hop count for the return path. Imagine sending a message across the internet. It doesn't just zip straight there. Instead, it hops through various routers, each adding a layer of complexity. With Traceroute back, you get a glimpse of the journey back home. Each hop represents a point where your data pauses, checks in, and moves on. This can help identify where delays or issues might occur. If the return path has more hops than the outbound, it could indicate a less efficient route. Understanding this can be crucial for troubleshooting network problems or optimizing performance. So, next time you're curious about how your data travels, remember that Traceroute back is your window into the intricate dance of packets across the internet.
When you're troubleshooting network issues, using the command Traceroute can be a game changer. This command traces the route packets take to reach a specific destination, but the dual D flag is key. It prevents the resolution of IP addresses to host names, speeding up the process and giving you a clearer view of the path your data travels.
Imagine you're trying to reach a website, but it's slow or unresponsive. By running this command, you can pinpoint where the delay occurs, whether it's at your local router, your ISP, or further down the line. Each hop shows you the time it takes for packets to travel, helping you identify bottlenecks. This socket-level debugging is invaluable for network engineers and tech enthusiasts alike.
It's like having a map of your data's journey, revealing the hidden obstacles along the way. So, next time you face connectivity issues, remember to use Traceroute to troubleshoot effectively and get back online faster.
When using the command tracer, Sport 1245, you're diving into the world of network diagnostics with a twist. By specifying the source port as 12345, you're not just tracing the route to your destination, you're customizing how your packets travel. This can be particularly useful for troubleshooting specific applications that rely on certain ports. Imagine you're trying to reach a server that only responds to requests from a particular source port. By setting it to 12345, you ensure that your packets are recognized and processed correctly. This command helps you visualize the path your data takes, revealing each hop along the way and identifying any potential bottlenecks or failures in the network. It's like having a backstage pass to the internet's highways, allowing you to see where delays occur and how your data navigates through routers and switches. So, the next time you're troubleshooting connectivity issues or optimizing your network performance, remember the power of setting that source port. It's a small tweak that can lead to big insights. When you run the command Traceroute, you're diving deep into the world of network routing. This command not only traces the path your data takes to reach its destination, but also reveals the autonomous system numbers for each hop along the way. Each AS number represents a unique network managed by an organization, giving you insight into the intricate web of the internet. As your packets travel, you can see how they bounce from one AS to another, which can be crucial for diagnosing connectivity issues or understanding latency. It's like following a digital breadcrumb trail. showing you the journey of your data. Plus, knowing the AS numbers can help you identify potential bottlenecks or even security risks. So next time you need to troubleshoot or just satisfy your curiosity about the internet's architecture, remember to use Traceroute and uncover the hidden layers of your online experience. When you run the command Traceroute, you're diving deep into the world of network routing. This command not only traces the path your data takes to reach its destination, but also reveals the autonomous system numbers for each hop along the way. When you run the command Traceroute, TCP-con, you're diving into the depths of network diagnostics with a twist. Unlike the traditional ICMP probes, this command forces a TCP connection for each hop, giving you a clearer picture of how data travels through the network. Imagine you're sending a message across a busy highway. The TCP connection simulates that message, ensuring it arrives intact and in order. This is crucial for troubleshooting because it reveals how firewalls or routers might be blocking or delaying your packets. You can pinpoint where the connection is dropping or slowing down, making it easier to identify bottlenecks. Plus, it's a great way to test connectivity to services that rely on TCP, like web servers. So, the next time you need to trace a route, remember, using TCP can provide insights that traditional methods might miss. It's like having a secret weapon in your networking toolkit. When using the tracer command, specifying the network interface can be a game changer. By adding the I flag followed by your interface like eth walk, You direct the tool to use that specific path for tracing the route to your destination. This is particularly useful in multi-home systems where multiple interfaces exist. Imagine you're troubleshooting a connectivity issue. By isolating the traffic ethra, you can pinpoint where the packets are getting lost. It's like having a dedicated lane on a busy highway, ensuring your data takes the most efficient route. Plus, it helps in understanding how different interfaces affect latency and packet loss. So next time you run a Traceroute, remember to specify your interface for clearer insights into your network behavior. When using the trace command, specifying the network interface can be a game changer. By adding the I flag, followed by your interface, like ETH0, you direct the tool to use that specific path for tracing the route to your destination. When using command Traceroute TOS16, you're diving into the world of network diagnostics with a specific focus on the type of service, or TOS, value. Setting TOS to 16 is all about prioritizing your packets in a way that can enhance performance for certain types of traffic. This value is part of the Differentiated Services Code Point, or DSCP, which helps routers make decisions on how to handle your data. By specifying TOS, you're telling the network to treat your packets with a certain level of importance, which can be crucial for real-time applications like VoIP or video streaming. It's like giving your data a VIP pass through the network, ensuring it gets the attention it needs to maintain quality and reduce latency. So when you run this command, you're not just tracing the route to your destination, you're also optimizing how your data travels through the complex web of networks. Understanding and utilizing TOS can be a game changer for anyone looking to enhance their online experience. When using the command tracer, flow label 100, you're diving into the world of IPv6 networking. The flow label is a fascinating feature that allows you to identify packets belonging to the same flow, making it easier for routers to handle traffic efficiently. By setting the flow label to 100, you're essentially tagging your data, ensuring it gets the attention it deserves as it traverses the network. This can enhance performance, especially in high-traffic scenarios. Imagine sending a VIP package through a busy city. The flow label acts like a priority lane, helping your data reach its destination faster and more reliably. So next time you're troubleshooting or optimizing your network, remember the power of the flow label. It's a small number with a big impact. When using the command traceroute, no fragment, you're diving deep into the mechanics of network routing. This option is crucial when you want to see the path your packets take without the risk of fragmentation. Fragmentation can obscure the route by breaking packets into smaller pieces, which might lead to confusion in diagnosing network issues. By disabling fragmentation, you're ensuring that each packet travels as a whole, allowing you to pinpoint where delays or losses occur along the route. This is especially useful in troubleshooting connectivity problems or optimizing network performance. Imagine tracing a route to a website and seeing exactly where the bottlenecks are, all thanks to this command. It's like having a clear window into the network, revealing the true performance of each hop. So, the next time you're analyzing a connection, remember, using tracer no fragment gives you that clarity, helping you make informed decisions about your network. Taking the output of a traceroute and saving it to a text file is super simple and incredibly useful for network diagnostics. First, open your command line interface, whether it's command prompt on Windows or terminal on macOS or Linux. For Windows, type traceroute followed by the website or IP address you want to trace. To save the output, just add output.txt at the end. So it looks like this. traceroute.example.com output.txt. Hit enter and voila. Your traceroute results are now in a file named output.txt. On macOS or Linux, it's almost the same. You use traceroute instead of traceroute, and the command would be traceroute.example.com output.txt. This way, you can easily review the hops your data takes without scrolling through your terminal. This method is a great way to keep records for troubleshooting or sharing with colleagues. It's efficient, straightforward, and a handy trick to have up your sleeve. Taking the output of Traceroute and saving it to a text file is super simple and incredibly useful for network diagnostics. First, open your command line interface, whether it's command prompt on Windows or terminal on macOS or Linux. When you run a command like traceroute, you're tracing the path your data takes to reach a specific server. Each hop represents a router along the way, and you get a glimpse of how long it takes for your packets to travel. But let's be real, who wants to sift through all that technical jargon? That's where grepms comes in. By filtering the output, you can focus solely on the latency values, which are displayed in milliseconds. This gives you a clear picture of how responsive each hop is. If you see high latency, it might indicate a bottleneck or a slow connection. So next time you're troubleshooting your network, remember to keep it simple. Traceroute, filter with grep, and you'll quickly spot any issues. It's all about efficiency in the digital world. When you run a command like traceroute NE, you're tracing the path your data takes to reach a specific server. Each hop represents a router along the way, and you get a glimpse of how long it takes for your packets to travel. When you run the command traceroute IM5, you're diving into the world of network diagnostics. This command uses ICMP, which stands for Internet Control Message Protocol, to trace the path your data takes to reach its destination. By setting the maximum hops to 5, you're limiting the journey, making it quicker and easier to identify where potential issues might arise. Each hop represents a router along the way, and with just 5, you can quickly spot if there's a bottleneck or dead end in your connection. It's like a mini adventure for your packets, revealing the route they travel and the time it takes at each stop. This command is essential for troubleshooting connectivity problems, ensuring your data flows smoothly across the internet. So next time you're facing a network hiccup, remember to give Traceroute IM5 a try and uncover the mysteries of your connection. Traceroute, or Traceroute, is an essential tool for anyone diving into the world of networking. It allows you to track the path your data takes across the internet, revealing each hop along the way. Imagine sending a message and being able to see every stop it makes. Pretty cool, right? When you run a Traceroute command, it sends packets to a destination and records the time it takes for each hop. This helps identify where delays occur, whether it's a slow router or a congested link. Understanding this can be crucial for troubleshooting network issues. Plus, it's a great way to visualize the internet's complexity. Each hop represents a different network, and you can even see geographic locations of servers. So if you're curious about how your data travels or want to optimize your connection, mastering Traceroute is a must. Dive in, explore, and don't forget to like, share, and subscribe for more insights.